Let's begin with the problem. Suppose the difference between the present ages of Tom and Harry is 6 years. 10 years later, the product of their ages will be 280. How old are Tom and Harry now? In this lesson, you will learn about quadratic equations and different methods of solving them. At the end of this lesson, you will be able to define a quadratic equation, solve a quadratic equation using one of the following methods: factorization, converting into perfect square, quadratic formula, and graphical representation. As per the problem, let us assume that Tom's present age is x years, so Harry's present age will be 6 plus x years. According to the problem, 10 years later, Tom's age will be x plus 10 years, and Harry's age will be 6 plus x plus 10 years, which is equal to 16 plus x years. Additionally, it is given that the product of their ages will equal to 280. Thus, x plus 10 times 16 plus x is equal to 280. On solving the equation, you get x squared plus 26x minus 120 is equal to 0. Equations where the degree of the variable is 2 are called quadratic equations. A quadratic equation is a polynomial where the highest degree of a variable is 2. The general form of quadratic equation in one variable is ax squared plus bx plus c is equal to 0, where a, b and c are real numbers. A is not equal to 0. The values that satisfy a quadratic equation are known as zeros, roots or solutions of that quadratic equation. There are 4 methods of solving a quadratic equation: factorization, completing the squares, quadratic formula, and graphical representation. We'll look at each of these methods in detail through the scenario about Harry and Tom's present ages. Let us first use the factorization method to solve the given problem. Consider the quadratic equation x squared plus 26x minus 120 is equal to 0. To solve this problem, you need to find x in the quadratic equation. You can do this in a number of steps. Step 1. Multiply the first and the last term of the equation. The product of the first and the last term is equal to minus 120 x squared. Step 2. Find the factors of minus 120 x squared in such a way that when you add them, the sum or the difference is equal to the middle term 26x. In this case, the factors are 30x and minus 4x. Step 3. Take a common factor x from the first 2 terms and minus 4 from the last 2 terms. You get x times x plus 30 minus 4 times x plus 30 is equal to 0. Step 4. Take x plus 30 as the common factor from the equation. Your equation becomes x plus 30 times x minus 4 is equal to 0. Thus, the roots of the quadratic equation are minus 30 and 4. As a person's age cannot be negative, the solution to the problem is 4. Therefore, Tom's present age is 4 years, and Harry's present age is 6 plus x is equal to 6 plus 4 is equal to 10 years. There may be problems where you find it difficult to determine the factors of the equation x squared plus 2x plus 2. In such cases, you can use another method to solve quadratic equations. This method involves the converting of the equation into perfect squares. Let's verify this method by taking up again the quadratic equation x squared plus 26x minus 120 is equal to 0. Step 1. Bring the constant value minus 120 to the right-hand side of the equation. The resultant equation is x squared plus 26x is equal to 120. Step 2. Divide the second term, 26x, into two equal parts. Each part is 13x. The diagram shows the corresponding changes. Step 3. The next step involves making the equation a perfect square. Add 13 square on both sides of the equation. You get x squared plus 2 times x times 13 plus 13 squared is equal to 120 plus 13 squared. On simplifying the equation, you get x plus 13 is equal to plus or minus 17. This means x plus 13 is equal to minus 17, or x plus 13 is equal to 17. Hence the values of x are minus 30 and 4. Therefore, the answer to the problem is Tom's age is equal to x is equal to 4 years. Harry's age is equal to 6 plus x years is equal to 6 plus 4 is equal to 10 years. Sometimes it may be difficult to find the factors in a quadratic equation or transform the equation into a perfect square. In such cases, you can use the quadratic formula to solve the problem. To derive the quadratic formula, let's start with the general form of the quadratic equation. Ax squared plus bx plus c equals 0. Step 1. Bring the constant c to the right side of the equation. You get ax squared plus bx equals minus c. Step 2. Divide both sides of the equation with the coefficient of x squared, that is, a. You get x squared plus b times x divided by a is equal to minus c divided by a. Step 3. Multiply and divide the last term by 2 to get the equation in terms of 2ab. The result is x squared plus product of 2x and b divided by 2a is equal to minus c divided by a. Step 4. You need to convert the equation into the form of identity. A plus b whole squared is equal to a squared plus 2ab plus b squared. To do this, add b divided by 2 times a whole squared on both the sides. Now you have x squared plus product of 2x and b divided by 2 times a plus b divided by 2 times a whole squared is equal to minus c divided by a plus b divided by 2 times a whole squared. On solving the equation, you get x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Therefore, the roots of this quadratic equation are x is equal to minus b minus square root of b squared minus 4ac divided by 2a, and x is equal to minus b plus square root of b squared minus 4ac divided by 2a. Now, you can try applying the derived quadratic formula to find the ages of Tom and Harry. First compare the quadratic equation x squared plus 26x minus 120 equals 0 with the general form of a quadratic equation, which is ax squared plus bx plus c is equal to 0. You get a is equal to 1, b is equal to 26, and c is equal to minus 120. The quadratic formula is x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. On substituting the values of a, b and c in the formula, you get x is equal to minus 26 plus or minus square root of 26 squared minus 4 times 1 times minus 120 divided by 2 times 1. On simplifying, you get x is equal to minus 30 or x is equal to 4. Therefore, as you can see, using the quadratic formula, you can verify the answer to the problem. Tom's age is equal to x is equal to 4 years. Harry's age is equal to 6 plus x years is equal to 6 plus 4 is equal to 10 years. Using the quadratic formula gives you certain advantages over other methods. Without actually solving the equation, the formula enables you to calculate the sum of the roots and the product of the roots. Now let's look at the sum of the roots. Let us consider the roots as alpha and beta respectively. Alpha equals minus b minus square root of b squared minus 4ac divided by 2a, and beta equals minus b plus square root of b squared minus 4ac divided by 2a. Therefore, the sum of the roots of a quadratic equation is alpha plus beta equals minus b minus square root of b squared minus 4ac divided by 2a plus minus b plus square root of b squared minus 4ac divided by 2a. On simplification, you get alpha plus beta is equal to minus b divided by a. Thus, sum of roots is equal to minus x coefficient divided by x squared coefficient. Now let's look at the product of the roots. The product of the roots of a quadratic equation is alpha times beta equals minus b minus square root of b squared minus 4ac divided by 2a times minus b plus square root of b squared minus 4ac divided by 2a. On simplification, you get alpha times beta equals c divided by a. That is, product of roots is equal to constant term divided by x squared coefficient. Let's again refer to the problem about Tom and Harry's present ages and use it to find the sum and products of the roots. X squared plus 26x minus 120 equals 0. On comparing the given equation to the general form of quadratic equation, you get a is equal to 1, b is equal to 26, and c is equal to minus 120. Now, apply the sum of roots formula. Alpha plus beta is equal to minus b divided by a. On substituting the values of b and a in the formula and simplifying, you get the sum as minus 26. Similarly, on applying the formula for product of roots, alpha times beta is equal to c divided by a, and simplifying, you get the product of roots is equal to minus 120. The roots obtained depend on b squared minus 4ac, which is known as the discriminant of the quadratic equation and is denoted by d or delta. You can use the discriminant to find out the nature of the roots that represent the answer to your problem. You can determine the nature of each root without solving the quadratic equation. If d is greater than 0, then the roots are real and distinct or unequal. If d is less than 0, then the roots are imaginary. If d is equal to 0, then the roots are real and equal. For example, let's consider the roots for the equation x squared plus 26x minus 120 is equal to 0. On comparing the given equation with the general form of a quadratic equation, you get a is equal to 1, b is equal to 26, c is equal to minus 120. Substituting the values of a, b and c in the formula and simplifying, you get d is equal to 1156. Since d is greater than 0, the roots are real and distinct. As mentioned earlier, you can also solve quadratic equations graphically. Let us consider the graphical representation method to find Tom and Harry's present ages. The quadratic equation is x squared plus 26x minus 120 is equal to 0. Let's assume y is equal to x squared plus 26x minus 120. As you can see, the table displays a list of ordered pairs based on the equation y is equal to x squared plus 26x minus 120. On plotting the ordered pairs on a graph, the curve of the quadratic equation y is equal to x squared plus 26x minus 120 emerges as a parabola. This parabola intersects the x-axis at minus 30, 0 and 4, 0. Since this parabola touches the x-axis at minus 30 and 4, the roots of the quadratic equation are minus 30 and 4. Therefore, Tom's age is equal to x is equal to 4 years. Harry's age is equal to 6 plus x years is equal to 6 plus 4 is equal to 10 years. The curve of the parabola varies based on the value of the coefficient of x squared, that is a, the discriminant b squared minus 4ac. Let's look at the impact of each of these factors on the parabola. First, let's consider the value of a. In a quadratic polynomial, ax squared plus bx plus c. If the value of a is greater than 0, then the parabola opens upward. If the value of a is less than 0, then the parabola opens downward. Now, Let's look at the impact of the discriminant on the parabola. If the discriminant value is greater than 0, then the parabola intersects the x-axis at two different points. If the discriminant value is less than 0, then the parabola does not intersect the x-axis. If the discriminant value is equal to 0, then the parabola intersects the x-axis at only one point.